Hello guys, welcome back to another video. In this video we will consider an integral from 0 to pi. Sum goes from k equals 1 to infinity, sine of kx divided by 2 to the k dx. So first we will interchange the summation and the integral sign. So sum goes from k equals 1 to infinity, integral from 0 to pi, sine of kx divided by 2 to the k dx. So this is an easy integral with respect to x. So we will have a sum running from k greater or equal than 1 to infinity minus 1 over k cosine of kx going from 0 to pi. So what will we have here? When you evaluate this, we will end up with 1 minus 1 to the k over 2 to the k times k. I don't have 2 to the k here, sorry. So we will have a sum looking like this. And if you split up the even and the odd terms, it will be equal to from k equals 0 to infinity 1 divided by 2 to the 2k times 2k plus 1. This is what we will have, because for even ones, for 2k we will have just 1 minus 1, which is 0, and for the odd terms it will be 2, and for odd terms I mean 2k plus 1, and we will have 2 divided by 2k plus 1, and it will cancel out, and we will have just 1 over 2 to the 2k. So that was it what we get, and let's solve this one. So what's the idea? We will consider a function phi of x, sum going from k equals 0 to infinity x to the 2k plus 1 over 2k plus 1. Why did we choose this sum? We choose this sum because if you realize, if we put x equals 1/2, we will have our original sum just without 1, 2. I mean, we will have 1 over 2k plus 1. So we will just have to multiply this with 2 in order to get what we need. So we will just need 2 phi of 1 over 2. 2 times phi of 1 over 2. So we need to find out what this sum is. Let's differentiate both sides with respect to x. We will have phi prime of x equals a sum going from k equals 0 to infinity x. We will have 2k plus 1 times x to the 2k divided with 2k plus 1. These two will cancel each other out, and we will have a sum going from k equals 0 to infinity, ugly infinity, x to the 2k. And what is this? This is just a geometric series with the first term being 1 over 1 minus x squared. And we found out what we need. Now we need to integrate backwards to get the phi of x. We don't need phi prime, we need phi. So integrate both sides. So we will have here phi of x again. And when we integrate the sum, we will have x to the 2k plus 1 divided by 2k plus 1. K goes from 0 to infinity. And the right hand side, it will be an easy integral just a partial fraction, which will be 1/2 ln of 1 plus x divided by 1 minus x. And of course the constant c of the integration. But if we realize that if we put phi of 0, I mean if we put x equals 0 into this expression, phi of 0 is just 0, and we will have ln of 1, which is just 0, so we will have phi of 0 equals ln of 1 times this 1/2 plus c, which is just 0 times c. So our constant is just 0. So we found out what our phi of x is. It's just ln of 1 plus x over 1 minus x times 1/2. And as we said, this is what we found. This expression is exactly this. So, but we have 2, in our original problem, we have 2 to the 2k, and we will have, if we put x equals 1/2, we will have 2 to the 2k plus 1. So when we multiply with 2, our result, we will get the thing we need. We will have 1 to the 2 to the k. So when we put phi of 1/2, which is just when x equals to 1/2 here, we will have ln of 3/2 up here times 2 multiplied by 1/2, which is just ln of 3 divided by 2. But we said that in order to solve our problem, we need to multiply the result by 2 in order to get 2 to the 2k, not 2k plus 1. So our main goal now is just to multiply these two out. 2 times phi of 1/2, and we will get the result 2 times ln of 3 over 2, which is just ln of 3. Alright guys, that was it for this video. Like, share and subscribe if you want to see more of this, and see you in the next video. Bye guys.